What do these two figures have to do with left and right, chirality, and configuration? In an earlier video, we defined enantiomers as mirror image isomers that are not superimposable on each other, and diastereomers as non-mirror image isomers. So stop the video and determine whether your left hand and right hand are enantiomers or diastereomers or the same. So the answer is, hold your left hand up to a mirror and the mirror image is your right hand. Put your left hand on top of your right hand and not superimposable on each other. So they are enantiomers. For question 2, a substance which is not chiral or achiral has a plane of symmetry or center of symmetry. So stop the video and determine whether each object is chiral. So the objects that are chiral are the pencil and cup of coffee have a plane of symmetry. Enantiomers, those non-superimposable mirror image isomers, have a chirality center. Look at a structure and a carbon that has 4 different atoms or groups bonded to it is called the chirality center. The configuration at chirality center is either R or S. The configuration tells us which enantiomer we're looking at. Once you identify chirality center, rank the atoms or groups bonded to that chirality center based on atomic weight. In our wedge and dash structure, here is the chirality center, which is a tetrahedral carbon. Bromine has the highest atomic weight, followed by chlorine, fluorine, and hydrogen. Point the lowest priority group away from it, which is the hydrogen, and draw a circle from the highest priority to the lowest priority groups. That circle goes in the clockwise direction, therefore that is the R enantiomer. Here's another example. The chirality center is circled in red. Then stop the video and study how the configuration for this molecule is determined. Note that H is the lowest priority group, so that's pointing away from you. Propylene oxide is the first chiral molecule found in space. So stop the video and answer these 2 questions. And the chirality center is, and the 2 enantiomers are. Remember, practice makes perfect, so stop the video, identify the chirality center, and determine the configuration of this molecule. So the chirality center is, the priority is, so the configuration is. More practice. Stop the video, identify the chirality center and configuration of each molecule. So the chirality centers are, and the configurations are. The pain reliever ibuprofen has 1 chirality center. Stop the video and mark the chirality center with a star. And the answer is, this structure of ibuprofen uses a dash to represent the direction the methyl group is pointing. Determine the configuration at that chirality center. And the answer is, note that the hydrogen points toward you. Going from highest to lowest priority, it goes in the clockwise direction. However, the lowest priority group points away from you. That's the H. So flip that molecule around so the H points away from you, and now it goes in the counterclockwise direction, which means it's the S configuration. Rather than using wedges and dashes, you can use a Fisher projection as a shortcut. So in the Fisher projection, the horizontal lines represent wedges, and the vertical lines mean dashes. NutraSweet is an artificial sweetener which is 180 times sweeter than sucrose. So stop the video and identify the chirality centers. And the answers are, wedges are shown in this structure, so stop the video and determine the configuration at the chirality centers. And the answers are, the R enantiomer of limonene has an orange smell. The S enantiomer has a lemon smell. Stop the video and identify the chirality center, then draw the R enantiomer. The chirality center is, and the R enantiomer looks like. Naproxen is a common over-the-counter analgesic. Ritalin is used to treat attention deficit disorder. Valium is used to treat anxiety. Stop the video and determine which compounds are chiral, and then determine the configuration of each chirality center. So the answers are, each chirality center is circled in red, and the configurations are